Hello viewers, you are welcome to this video lecture. I am here to present the third video lecture from chapter 1. Chapter 1 deals about the highway route survey and the locations. In the previous videos will be deals about generally introduction about the highway route survey and locations. Also deals about the importance of transportation and for major disciplinary of transportation also will be deals in introduction parts, and also will be deals about the basic important requirements for selecting highway. For example, it is alignment will be safe, easy, short and economical, and also will be deals about the factor controlling alignments. There is for example obligatory points. The alignments has passes, for example a bridge sites, intermediate towns, and also the second part is the alignment has not passing. For example, it is acoustic structures, cultural heritage places, marsh, lowland areas. Mostly it is affected by flooding, and also factors that are the traffic volume, the geometric and economy is very important factors, and also will be starting the engineering survey for highway locations. There are four major highway routes surveying. The first one is a reconsistent survey, the second is preliminary survey, the third one is final location survey, and construction layout survey is very important in route surveying. So today's will be deals about the preliminary survey. From those reconsistent surveys, so select some best alternatives. For example, from 10 alternatives we have select 4 or 5 alternatives. So the 5 alternatives will be passing to the preliminary survey. So this preliminary survey is carried out to collect all the physical information necessary in the connection with the road alignment. So we have conducted on the site. So the major main objectives are to survey and various alternative alignments proposed after a reconsistent survey, to compare the different proposals in view of requirements for good alignment, to estimate the quantity of the earthworks, material and other construction aspects, and to work out the cost of on alternative proposals, and also lastly to finalize the best alignments for all consideration by using different requirements. So this preliminary survey conducts approach with two approaches. The first is modal rapid approaches. This modal rapid approaches is by using aerial survey or using the aerial photographs and using photo interpretations techniques to obtain the necessary topographic and other maps, including details of soil and geology, and dense will be a strip of lands along the center line. The first will be modern by using a photograph, aerial photographs. Conventional, mostly in Ethiopia, also will be conduct this conventional approach in which a survey parties carrying out survey using the required field equipments, taken measurements, collecting topographic and other data, and carried out soil surveys on going to the site. So these conventional methods will be different procedures. The first is primary traverse. The line recommended from the reconsistent survey. Primary traverse is established, or 10 or different more than 10 alignments. Topographic features, establish a center line. Leveling is carried out to give center line profiles and typical cross sections, and also will be hydraulic and drainage data. Soil surveys is essential parts of preliminary surveys, as a suitability of the proposed locations is to be finally decisions by using the soil survey data. After collecting the data from preliminary survey, carrying alternative proposal for the alignment and comparative study will be made. So after this will be finally the most suitable alignment are selected from the various alternative. So we have only one best route. So after selecting the best routes, come to the final location survey. So this will be the final location survey is fixing the center line on of the selected alignment in the fields, and to collect additional data for the design and preparation of the working drawing. If the preliminary survey has been done properly, the data collected works during the final alignment survey will be limited. So the detailed ground survey will be carried out by using different updated equipment such as total station, GPS to examine the road alignment. In final location surveys will be generally survey is pinging the center line. The center line is pinged with a reference to the preliminary traverse if conventional survey methods by using total station or GPS, and also will be using the aerial survey methods, and the other is center line leveling. So the professional profiles are taken along the center line at each stations and all at intermediate points where there is any significant changes in the slope of the ground, and also cross-sectional leveling. So we have the first we have established the center line, so we have established a cross section by the required width. It is very simple, and also will be placing intersections. So the directions with respect to the peaking center lines of all intersecting roads should be measured. So the profile and the cross sections of intersection roads should be taken for some distance on both sides, and also will be placing the ditches. And the other part is the drawing and report. So after we are placing the data's final locations, so it is sent to a design office where it is suitable processing with regarding to the geometric design, drainage structures, and the pavement design. So different disciplines will be conducted. However, highway working drawing should be accomplished with the report and specification of the design. Each material will be their own specification, as well as estimation of bill of quantities. The total cost of the road also will be done. The drawing of road construction includes the following: site plans, plan and profiles. The whole plan will be related to the horizontal alignment and the horizontal straight line, and profile related to the vertical alignment, typical cross sections, mass-hole diagrams, the cut, fill, and the distance also will be placed, and the other one is details of the structures. There is drainage structures, culverts, tunnels, all drainage structures will be conducted. And the last one is the construction layout survey. This will be the first is preparation and scopes. So the construction, after the design, after the layout, coming to the construction. The construction layout is an instrument surveys, provide the alignment, grades, locations that guide the construction operations. The construction operation includes from the clearing, site clearing, gripping, trees or the topsoil will be removed, drainages, rough grading, finishing grades, surfacing up to the surface, the top part will be as a construction parts. And the second one is alignment. Survey must place the alignment markers ahead of the crews engaged in the various phases of the construction. After we'll be placing the center line, we'll be placing the cross sections with the widths. And also the surveys will be hastily alignments marked by flags and rods suitable for guiding the clearing and gripping operations. And also survey marks the curves, minor structures concurrently with the layout of the center lines. Major bridge structures, for example tunnels, bridges involved inside survey also will be, the surveyor will be mark flags. And also setting grade stickers. Grade stickers indicates the exact grade elevation of the construction forces. So the surveyors consults the construction plans to determine the exact elevation of the subgrades and the distance from the center line to edge of the shoulder will be placing. Preliminary will be subgrade stickers. So the placing of the subgrade will be placing. The survey sets preliminary subgrade stickers on the center lines and other grade lines as well as the required. So how much cutters, fillers required as the center line sections will be determined by the subgrade stickers. The amount of cuts and or fillers is equal to the grade rod minus the ground rod. So for example the grade rod will be equal to the height of instrument minus the subgrade elevation. So the height of instrument minus the last subgrade elevation will be get the grade rod. So after this, the results of this computation is a positive value, indicates the amount of cut. It is negative, it is some amount of filling with needed. For example, if how to calculate, we'll see how to calculate the ground rods as well as the grade rods will be for example as examples. So for example, give a height of instruments 115.5 feet. Subgrade elevation is the subgrade is the last elevation is 108.6 feet. So and the ground rod reading of 3.1 feet. The grade rod will be calculated as the height of instrument minus the subgrade elevation 115.5 feet minus 108.6. There is a positive 6.9. This indicates as it is positive. So we have the cutting or filling will be calculates as 6.9 minus the ground rod, so this gets it is a positive 3.8. it is a positive, so indicates it is a cut. So we have the survey recording the results and field notes on the back of the grade stick C38. So we have C in the figure below. The final grade stickers also will be placed. The final is the top of the final grade stickers will be it is a blue topaz. The elevation of the final grade is determined and the value of the grade rod's reading is computing. So we have for example we have C. There is two type of systems, English systems and metric system. Ethiopian mostly uses the metric system. So at center lines will be 214 meters, and also will be see the ground level. And C means it is a cutting. For example, 1 the and 1.6, so this will be 1.16 meter. It is the cutting part. The cutting part below it is 0. 0 means this one is 0. 0 means it is the plague will be at center line, and also the cutting will be 1.20 at 0, and also fill 1.0, and we have placing at 4.29 meter away from the center line. And also the survey should provide blue topaz on all grade lines. However, the final decision have to be what the stick are required lines with the construction formal. So there is a special cases. Special cases will be used. The grade sticks does not be driven. It is the area with rocky areas, so we have use chisel instead of the stick. Setting slope stickers will be indicates the intersections of the cutting or filling slope with the natural ground lines. And level sections, at the level sections will be when the ground is level, there is no grade elevations to the center lines of the road. The cutting and or the fills at the slope stickers will be the same as at the center. There is no grade difference. On the fill sections, the distance from the center stickers to the slope stickers is determined by multiply the center cut by the ratio of the slopes. For example, horizontal distance to the vertical distance of the side slopes and adding 1/2 of the width of the road width. So this one is we have C in calculation parts. On the cutting sections also will be the surveyor can find the distance from the center sticks to the slope sticks by multiplying the ratio of the slope by the center cuts and adding the distance from the center line to the outer side edge of the ditch. So for example, we have see the calculation part. In cutting sections there is the ground the grade roads will be it is a positive. So the cutting sections will be below. We have level set ups with height of instruments. The height of the instrument is 388.3 feet. The subgrade elevation is at this center line stations is set at 372.5 feet on 23 feet the width, the road bed width, and the slopes is 1.5 to 1 side slopes, and after the drainage ditches 7 feet ditches, there is a shoulder 4 feet. So the grade road is the difference between those two elevations. So the height of an instrument 388.3 minus 372.5, so it is a positive. The grade road will be a positive of 15.8 feet. So now we have gets information from the roadman. The roadman collects the height of the ground at the center. Reading is 6.3 feet. So this one is the record subtraction is 6.3 from the grade road of 15.8. we have gates positive 9.5 feet. So this is it is a cutting at the center from the center. 9.5 feet will be excavated, and also we'll have done the slope stickers. So the slope stickers will be gates from the formulas. The formula is the 9.5 or the ground road minus the grade road. 9.5 will be times by the slope 1.5 plus 22.5. How to get the 22.5? It is addition of half of the road bed. It is half of 23 means approximately 11.5 plus 4 15.5 plus 7, it is 22.5. so we have the back of the road sticks will be 36.8. so in the drawing also will be that the height of an instrument is 388.5, and also will be adding the ground. The subgrade elevation is 372.5. Subtract 2 the height of an instrument with the subgrade. It is positive 15.8. So when we say the ground from the road, the main road, will be getting 6.3. So we are minus 50.8 minus 6.3, we have get 9.5. so this is a positive, means we have cut these parts almost 9.5 will be cut. So we have get the slope stickers. So we have get 36.8 from 36.8. so we have placing a roadman will be the ground road, so reading will be 9.1. so the roadman will be at the 36.8. there is 9.1, it is obtained. So from 9.1 will be subtract 15.8, we have get 6.7. it is also will be cut from 6.7 will be calculate will 6.7 times 1.5 plus 22.5. so we have get 32.6. so we have placing 32.8. so placing to 30 points, the road will be 8.9. so from 8.9 also will be calculators. At 15.8 minus 8.9, it is, we get 6.9. so this 6.9 will be times the slope 1.5 plus 22.5, half of the road, plus the shoulder, plus the drainage. We have get 32.8. it is similar to that one. So the cutting slope sticks will be cut 6.9. so the road, the surveyor will be mark or placing C6 in the top 9. so 6.9 will be, it is the cutting part. This is a cutting part. At what distance? 32.8 from the distance from the center line. And the fill sections also will be, that one is the cutting section. The fill section is also two parts: height of instrument above the ground elevation, as well as height of instrument is below the ground elevation. So it is, for example, it is similar to that one. And also will be the subgrade elevation is 31 feet road beds, and the grade roads will be always less than, because the height of instrument is above the ground elevation. So the grade road in this problem is positive 2.8. so the center sticks will be read 6.5. so minimum minus the difference 2.5 minus 6.9, it is a negative indicators. It is a cut section, so 3.7 feet will be fill. So this one is the subgrades will be this one, the subgrade will be this one, and height of instrument will be this one. So in these cases will be the cross sections, or the cross sections will be at from origin, above the origin of the ground. The fill section is also height of instrument is below the ground elevation. So this one is also will be, we have seen the height of instrument is below the subgrade elevation. Thank you for listening to my video. The rest topics will be covered in the next video lecture.